Hello everyone. Hope all are learning chemistry with a desire. Let us move to our today's video lecture. The objective of this lecture is to provide an insight about electrochemical cells, electrodes type, significance and application of electrochemistry. Let us get into the lecture with this small prerequisite test which can make you to recall the knowledge related to electrochemistry. Hope you clear all questions and has given an overview of this topic. Here comes the question, how electrochemistry is useful for us? Few real-time applications of electrochemistry are fully automatic cameras, electrical cars, and other electronic gadgets which run with batteries. Even our nerve system also working with electrical pulses generated by neurons, which led to the invention and research in the field of artificial intelligence. How electrochemistry is useful for an engineer? That means, what are the learning outcomes? After understanding and after learning electrochemistry, an engineer can able to design efficient routes for storing electrical energy in the form of chemical bonds. An engineer can develop sustainable fossil-free pathways to produce fuels and chemicals of global importance. An engineer can decrease the carbon footprint of energy generated and used by electrochemical approaches. That means, with the basic principle of electrochemistry, engineer must be able to prepare advanced appliances which are environmental friendly. With this slight introduction and prerequisite test, now we will get into our topic, electrochemistry. In the name only, we are having some information. In this topic, electricity and chemistry both are having a relation, right? Electrochemistry is a branch of science which deals with interconversion of electrical energy into chemical energy and vice versa. Electrochemical conversions can be observed in a physical entity called electrochemical cell. Here is the simple electrochemical cell, voltaic cell, a physical entity consisting of anode, cathode, in which simultaneous oxidation reduction reactions can be observed, which is capable to generate electricity by a spontaneous chemical reaction, or chemical reactions can be generated by electricity. That means in an electrochemical cell, simultaneous oxidation and reduction reactions can be observed. Here comes the question again. What is oxidation? What is reduction? Oxidation means loss of electrons. Reduction means gain of electrons. Here in this given voltaic cell, zinc is undergoing into oxidation by losing its 2 electrons. Copper is undergoing into reduction by gaining electrons. This can be illustrated by a simple copper-zinc chemical cell. Let us zoom into the atomic scale and see how this cell operates. Here at the anode, the side of oxidation, zinc atoms, which are at the middle bar, are in contact with the surrounding electrolyte solution. Each atom loses 2 electrons and become zinc ions. And zinc ions diffuses into the ionic solution. And the electrons flow up towards the cathode through an external circuit. they flow into the cathodic side of reduction. When copper ions consumes these electrons, they get reduced to copper atom and get deposited on the bar. Therefore, as the cell works, the zinc electrode become lighter and copper electrode become heavier. Now we will look into the salt bridge. The non-reactive sodium ions prevents buildup of zinc ions and copper ions to maintain electroneutrality of ionic solution. When an electrode is in contact with its ionic solution, there may be the loss or gain of electrons.